So here, what is our purpose today, beta? We will determine the distance formula. We will just utilize the derive the distance formula. So see here, suppose the coordinates of this point P1 is x1, comma y1, and the coordinates of this point P2 is x2, comma y2. Now it is very much important that you must know the meaning of this coordinate x1 comma y1. That is why I have told you the allocation of the point in the terms of xy. This x1 means what? You have to move x1 steps in along x-axis, that is this, and after that you have to move y steps along y-axis. Then you will reach at point P1. That is the thing, that is the true meaning x1 comma y1. Now let us understand here, beta, that what we are willing to determine the distance between this point P1 and P2. Let me join by a straight line so that it will be clear to you what we are willing to do here. We are willing to just determine this line length. Actually, this line is joined by these 2 points. Are you getting beta what I am saying? Now
Yes.
see what we will do. Just you can observe. Just you can observe that. Just I will draw the small projections over here. Projections of this point, and sorry, this is not very straight. This point. Okay. Now see what happens. What happens? Here we can see. Here we can see that this distance that you are observing is x1, edge x1, very clearly. This is x1, and now the second distance that you will observe from here to this projection is x2. That is the true meaning of x1 comma y1 and x2 comma y2. On that it is based. And if I try to draw these 2 points y coordinate, very easily I am able to see that this side, this one is y1, and this one is y2. See here, beta, very easily. Of course, it is a very easy to understand, beta. Just I will project this. Just I will draw a perpendicular line from here to here. That is perpendicular. Now see here, beta. You are observing a right angle triangle here. Let me name this point as M. So you are observing P2, P1 and M be a right angle triangle, in which if I term this as base, what I get? See here, beta. The distance between this point and this point will be x2 minus x1 along x-axis, and here the distance from P to M is very clearly y2 minus y1. Is it?
Yes.
Are you getting this, beta?
Yes.
Now you know Pythagoras theorem. That tells us
Yes.
that this P1 P2 is hypotenuse. Hypotenuse square is equal to base square, that is equal to P1 M square plus P2 M square. Nothing to be confused here. Just okay. Now P1 P2 is the distance between the 2 points, that is distance square. Here P1 minus M, P1 M, you can see P1 M, very good, that is equal to x2 minus x1, x2 minus x1 whole square, plus P2M, that is you are observing here y2 minus y1, so you are getting y2 minus y1 whole square. Very clearly here we are getting beta, that is equal to under the root of x2 minus x1 whole square plus y2 minus y1 whole square. This is what? This is distance formula. This is distance formula. It is just determining the distance between the 2 points of the coordinate system. Have you got this?
Yes.
Okay, beta. Suppose if you are given some points, let me mention 2 or 3 points so that you can be very much clear about that. Suppose a point P1 is given, that is 2 comma 3, and point P2 is given 3 comma minus 1. And remember beta, you can treat x2 and x1, you can take on your assertion, on your perspective you can take. And it is not fixed that you have to always take P2 as x2, y2 and P1 as x1, y1. Whatever order you want, you can take. That is freedom here. Because the square of anything that is the real number is never negative. And that is that property of actually quadratism gives us freedom to put the value. See here beta, if I wish to determine the distance between P1 and P2, simply what you have to do, I will tell you in a very simple steps. Just write here, never be confused, write x1 comma y1, here write x2 comma y2, so that you can never get confused. Okay, because there is a simple formula, always students do mistake in putting values, so that is why for that confusion should be removed here. Just you see the value of x1 is 2 and y1 is 3. Here the value of x2 is 3 and y2 is minus 1. Just you have to determine the distance. So you will just put this value in this particular formula. That is x2 minus x1. See here beta, 3 minus 2. So you will put here 3 minus 2 whole square plus y2 minus y1, y2 is minus 1, you can observe here minus 1 minus 3, minus 1 minus 3 whole square. Very easily you can get what, 3 minus 2, that is equal to 1, 1 square is 1, plus 3 minus 1, minus 3 minus 1 is minus 4, minus 4 square is 16. Are you getting my point beta?
Yes.
So here we will get under root of 17 units. So just you can determine by using this formula the distances between the 2 points. Are you getting my point?
Yes.
Okay, beta. This distance formula can also be used to determine whether the 3 points given are collinear or not collinear. Do you know what is the meaning of collinear, beta?
Yes, they lie in a straight path.
They lie on a straight line. Whatever the points that they are lying on the same line, that are collinear one. Actually, this distance formula can also be utilized to determine whether the given points are collinear or non-collinear. Let me tell you, there are two methods to determine the collinearity and non-collinearity. Actually, three methods that I will tell one by one. Let me tell by this method only. Let us take 3 points. Let us take 3 points so that you will be able to understand better. Suppose if I take point 1 comma 2, 1 comma 2, second point 1 comma 3, and third point I take 1 comma 4. Just for the sake of simplicity, I have taken a sequence of points so that you can understand the application better. Now see, actually what happens. If you are dealing with 3 points, and those are collinear, it means what? The single point must lie in the middle of the 2 points. One point has to lie in the mid between. What you
Yes.
have to do, you should determine the distance between the points. Let me name these points P1, P2 and P3. What you should do, just by common sense we can observe here. You should determine the distance between P1, P2. You should determine the distance between P2, P3, and you should determine the distance between P1 and P3. What will happen? What will happen then? D1, D2 and D3. If these points are collinear, then the summation of D1 and D2 must be equal to D3. Otherwise, it will never be equal.
Yes.
Are you getting my point? If
Yes.
if there is something like that, point are lying this, then there will be never equality. Equality will be never supposed. It means if you are determining the three distances between these 3 points and you are getting the summation of two distance equal to the summation of one distance, that is the longest one, so that you will you must understand that these 3 points are collinear. Otherwise, they are not. Have you got?
Yes.
Let us apply this procedure for this particular example, that we know that these are the collinear ones, but let us do apply. And what we are observing here, let us check that. So let this be point P1, this be point P2, and this be point P3. So first I will try to determine distance D1, that is P1, P2, that is P1, P2. The formula should be always written, beta. That is very important, that x2 minus x1 whole square plus y2 minus y1 whole square. Very clearly, here you can observe, x1 are cancelled, x2 minus x1 are cancelled, 1 minus 1 is 0. So you can write, whether you write or not write, it is your choice, but 1 minus 1 will be 0 square, plus 3 minus 2 whole square, 3 minus 2 whole square. What I observe here, 3 minus 2 is 1. 3 minus 2 is 1, and the root of 1 will be 1. So that is why result is 1. Okay. Now let us move to the next step, that is D2. D2 is the distance between P2, P3. And remember, another very important point I am telling you, remember that it need not to be in sequence, that this here this P1, P2, P2, P3 will be equal to P1, P3. But it need not to be in sequence in any general problem. I have taken this example such that these are in sequence. What if these points are written in altered form? So there you have to think like that. The longest distance must be summation of other two distance for the points to be collinear. Are you getting my point? So
Yes.
don't get confused just by following the sequence. You must be very much clear about that. Okay. Now see here,
Yes.
beta. That is D2 is equal to P2, P3, and P2, P3. Here we are observing 1 minus 1 is 0. So very clear. Under root. Uh, Once again, formula must be written. That is very important. Every time formula must be written so that you don't get confusion and your steps are clear to the examiner. That is also very important. So here 1 minus 1, that is equal to 0, but we have to write, and here 4 minus 3 whole square. Once again, beta, we have observed the result to be 1. Now I have to determine D3, that is P1, P3, P1, P3. Once again, just you will put the values in the formula, respective formula x1, no sorry, x2 minus x1 whole square. plus y2 minus y1 whole square. Just put the value, what you will get. Just let us see that. Here I am observing 1 minus 1, 1 minus 1 is 0, 4 minus 2, 2 square. Okay, let us see that. Here I can write 1 minus 1 whole square plus 4 minus 2 whole square. The result is 2 beta. You are observing that this 2 is the summation of this 1 plus 1. It means what? It means what? These 3 points must be collinear one.
Collinear. Yes.
These 3 points must be collinear. Any doubt?
No.
Okay. So we have understood a very peculiar usage of this, determining the distance between the 2 points, that we can also prove or we can also detect whether the given points are collinear or not. Okay, beta. Let us move to the next section of your chapter. That is also very important. So we have understood about the distance determination by using the distance formula, and there is exercise based on that. Okay, every concept of this exercise I have discussed with you. But see here, beta, there is a question. Just I am bringing that question to your screen, and we will observe there is very nice question it is, and we will learn some of the concept related to that. Just I am bringing that to your screen. Just I am trying to bring that. Like this, many times questions are being asked. Is it readable to you, beta?
Yes.
Hello.
Yes.
Anandya? Okay, beta. Now let us see that. Find the values of y for which the distance between the points P and Q is 10 units. Like that also questions are asked, but these are very easy. You have to just utilize that formula and you will be able to determine the value of coordinate. Are you
Yes.
getting where this application must be used?
Yes.
Where?
Yes.
In practical life.
In practical life,
Yes.
we can use it for determining maps in which we have been given that 1 unit 1 centimeter in this
Okay,
map is
very
equal
good.
to.
Very good. Any other example?
No. No.
Suppose if you have to throw anything, if you have to throw anything and you are just supposed to know the distance and you are knowing the x coordinate, then you must be aware about the y coordinate, how much it should be thrown. Are you getting my point?
Can you explain once again?
Suppose if you are painting a wall and you are having a spray, and you are standing 5 feet away from that wall, and you are knowing that distance from your hand to that point where you have to throw the paint. So that you have to determine the y coordinate, at what height we will be painting that. So that will be also determined by using this formula. That is also the practical application. That can be also the practical application. Not for humans it is required, but for robotic application it is also required.
Yes.
Are you getting my point?
Yes.
Okay, beta. Another example. Any other example? Just for the sake of knowledge, I am taking a question is very easy. We will solve it. Any other example? Just see the bridges where the ropes are tied up. The length of those ropes are known, but how much it will go down that bridge, the arc will go down, that can also be determined by using the formula. This basic formula can be utilized in such big applications. Just you people are studying base of everything. That is why I am telling you. Just open up your mind. Okay, beta. Now,
Yes.
uh, in this question, you are available with 2 points, P and Q, and Y is unknown here. You can use it, the formula, the distance between PQ. So here, this point 2 is x1, y1. Here, this is x2, y2. No doubt. That is PQ is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square. Very easily, we are having PQ. PQ is the distance that is equal to 10. Here given it is. Now you can put the value of x2 minus x1. Very clearly, beta, we have the value of x2 that is equal to 10. X1 you are having that is 2 plus y2 minus y1. So y2 I don't know, that is y, and y1 I know, that is minus 3. And you know minus into minus will become plus. That is why I have written here plus 3. Okay, beta.
Yes.
Now I think you are able to solve that. Just to remove that square root, you have to square both sides. You will get here 100. Here you will get 8 at just 64 plus y plus 3 whole square. Y plus 3 whole square. Now to be very sure, we can get 100 minus 64 is equal to y plus 3 whole square. You can see here beta 64 that is equal to 36 and here y plus 3 whole square. Here some of the students get confused, but we can think like this, that y plus 3 whole square minus 6 square is equal to 0. A square minus b square is the right formula to be used here, that is a minus b or a plus b. I can see that y plus 3 minus 6 that is a minus b and y plus 3 plus 6 that is a plus b is equal to 0. Here I have got y minus 3 into y plus 9 is equal to 0. No. Now see here beta, y minus 3 is equal to 0, then y is equal to 3 or y is equal to minus 9. So these are the two values of the y that you have got due to the coordinate nature of the system. Any doubt?
But y plus 3 is equal to y plus 3 the whole square is equal to 36. So we can just under root it. It will be 6 plus minus 6 is equal to 3. Plus minus 6 is equal to y plus 3. And then we can put it like plus minus 6 minus 3 is equal to y.
Yes, yes, beta, that is also right. But sometimes you people do mistakes. Suppose this is that is why I have used this formula, because and I develop every student in my every student this habit to do. Now the question is why. Question is that beta, suppose if you are available with x is equal to under root 4, what is the answer of this?
X is equal to under root 4.
What is the answer of this beta, Anadi, according to you? And
X is
another
under root
question,
2. 6 is
x
2
is
plus
x
minus
is
2
equal to 2. And
plus
another
minus.
question, x square is equal to 4. What is the answer of this?
Uh, uh, it will be x is equal to plus minus 4.
X is equal to plus minus 2.
Sorry, plus minus 2. And there also I said plus minus.
Here also you said plus minus 2.
Yes, it will be plus minus 2.
That is the mistake. For removing that mistake, I was practicing that formula. Now see Anadi, why? Because beta, you have learned in quadratic polynomial that the degree of equation is equal to number of solutions of equation. Here the value of x, you are observing the power to be 1. Linear power, the answer will be only plus 2. Here you are observing the power to be 2. You are utilizing same root, but the roots will be 2. That is minus 2 and plus 2.
Oh.
That is why to remove this confusion, of the roots, that if you are squaring anything, redundant roots are introduced. If you are doing square root, some roots are deleted. So that to remove that confusion, I always use this method so that you will never get confused. Have you understood this?
Yes.
Okay. Any other doubt?
No.
Any other doubt, beta?
No.
Okay. So we have understood a very important problem of this portion. If you want to note, you can note it down, beta. This is a very important problem that we have to do. Sometimes beta, the relations are given, that is you have to determine the relation between x and y such that the x and y are the equidistant from the given point. Like that questions are also asked, so that we will understand, also understand. See here beta, another type of question that is asked in your book. Just you can observe it. Mm, what happened here? Is it readable to you now?
Yes.
Okay. Here the relation between x and y is to be determined. It means what? They are expecting a relation. They are expecting a form of equation in the terms of x and y. So that for every x and y, this 3, 6 and minus 3, 4 are equidistant. Are you getting? What question is expecting from us?
Okay.
Now see here beta, Anadi, whenever you get such questions, what you have to do, how to approach such question, that is very important. According to my point of view, what you should do, just for in rough work you can do, or inside you can mention that you can draw a line, simple line, and you can draw 2 points. You can mention here, that is minus 3 comma 4, and here you can mention 3 comma 6. Why I have written it in left? That is my common sense. That is minus 3 is lying in this side. That is why I have written that. You can do it any manner that you wish. Now what you should do beta, just you have a point x comma y in between them. Just always treat this xy as x2 y2. This is my suggestion to you. Just always treat x2 y2, so that we do not have to bother about, we have to only bother about the distance. But here a very important term is used. You can see very clearly, that is equidistant. Equidistance means what? Equal distance means equal distance. What we will do? Very simple. Let this point be A, this point be M, and this point be B, so that we can assign the points. So here we will determine the distance between AM. So the distance between AM is equal to, you can see this x minus minus 3. Here you will get x plus 3 whole square and y minus 4, y minus 4 whole square. By using the distance formula, you can write the distance formula in initial stages. That is, you know that the distance between 2 points is x2 minus x1 whole square plus y2 minus y1 whole square. Now see here beta, we have determined the distance m. After that, no need to just solve that and expand those terms. Don't do that. Don't do that. What we have to do? Then determine the distance between m and b. M and b. Very easily you can do this. That is x minus 3 whole square plus y minus 6 whole square. But don't get confused. You can write here 3 minus x square and 6 minus y whole square. Nothing different will be there, because a minus b whole square is equal to b minus a whole square. You can use the formula, you will get the same result. Now see here beta. According to question, this m is equal to mb. Just I am putting the values, and here I have x plus 3 whole square plus y minus 4 whole square is equal to under the root of x minus 3 whole square plus y minus 6 whole square. Now see here beta, both side square roots are there. They can be removed by just squaring LHS and RHS. You can observe x plus 3 whole square plus y minus 4 whole square is equal to x minus 3 whole square, y minus 6 whole square. Can you tell me the formula of a minus b whole square?
A square plus a minus b, a square plus b square minus 2ab.
Okay. And for plus, you know, plus 2ab will be there. So here we will get x square plus 9 plus 6x. Here for y minus 4 square, we can get y square plus 16 minus 8y very easily. Here you will get x square plus 9 minus 6x plus y square plus 36 minus 12y. Okay. X square is lying both side, y square is lying both side. This will be cancelled. And any other thing we are left with? Yes, 9 is also cancelled. And any other thing? Okay, no. Now I will move all the variables one side and all the constants one side, so that I can get a particular relation. That is the relation between x and y. See here beta, 6x and here 6x is in negative form. So here we will get 6x plus 6x. Here we are left with 8y, and this 8y minus 8y actually, and here we are available with minus 12y, so that will go this side, so that will be positive 1. And here you can see plus 16 and here 36, so I can write 36 minus 16. Anything left beta?
No.
So you are left with 12x plus 4y is equal to 20, or you can simplify this relation just by dividing by 4 this whole equation. You can write, your answer is complete here. Okay, but for simplifying the equation you can divide by 4, because 4 is the common factor here we can take. So that I will divide by LHS and RHS, both RHS and LHS will be divided by 4. So here I will get 3x plus y is equal to 5. So many a times you will get the answer in this form. Have you got?
Yes.
So these are the points. It means what? The xy is being related by this manner will always be equidistant. Will always be equidistant from the those 2 points that are mentioned in the question. Okay.
Yes.
Okay, beta. So we have discussed each and every form that is related to distance formula. That is related to distance formula. Another type of questions are asked there, beta. See here. But for that you must be uh, aware about the properties of the geometry, properties of the some geometrical quadrilaterals. Inside your book, certain questions are asked that determine whether the given quadrilateral is a rectangle, is a square, or a rhombus, or a parallelogram. You must be aware with the properties. You must be aware with the properties. If the opposite sides are equal, if opposite sides are equal, then it comes under parallelogram.
Hmm.
And
Yes.
if the opposite sides are equal and diagonals are also equal, then it comes under rectangle. Are you
Yes.
getting my point?
Hmm.
Third property is that beta, if all sides are equal to each other, that comes under rhombus. And along with this equality of all sides, if the diagonals are equal to each other, that will become a square.
Hmm.
And for doing that, what you have to do? You have to determine the distances between the points. You have to determine the distances between the points, nothing more than that. Are you getting my point?
Yes.
You can take any example. You can take any example. Just you have to determine. Remember, beta, there you have to determine 4 or 6 distances. Whenever, just I am telling you, whenever you are getting two pairs of distances to be equal, two pairs of the lengths to be equal, it means what? That is lying in criteria of parallelogram. Then you should determine the diagonals, the length of diagonals also. Then you will be confirmed that whether it is a parallelogram or a rectangle. If diagonals are equal, then that will be rectangle. If diagonals are not equal, then it will be parallelogram.
Hmm.
And a rhombus with equal diagonals will be termed as square.
Okay.
Have you got? Similarly, you
Hmm.
can decide the type of triangle also. You can decide the type of triangle also. If 3 points are given, you have to determine the 3 distances. If all distances are equal, then that is
Yeah.
equilateral triangle.
Hmm.
If two sides are equal, then it is isosceles
Isosceles.
triangle. And if it is none of the sides are equal to each other, then it is scalene triangle. That is the thing. Have you got?
Hmm. Yes.
So you are observing here that different geometrical figures nature is being determined just by using this distance formulas. And in this particular chapter we have learned that how to determine the distances between the 2 points, and the application part of that is very much you will learn in your higher classes also, but here we have discussed a little bit about that. Are you left with any doubt with this
No.
formula?
No.
Okay, beta. So I am expecting you to solve the whole exercise based on this. This is the exercise number 1 of the coordinate geometry. You can see your book. That is the first exercise. You will not get any trouble in solution of any question if you have understood this lecture.
Hmm.
Okay.
Okay.